everyone. Now we're in chapter 3. All right, so chapter 3, we basically started really trying to understand what a function is all about. Now, function is also, it's a relation. However, function is a very special relations. So later on, we will touch upon that concept or study that concept more carefully. But in 3.1, we just want to talk about mathematically what relation is all about. In fact, I do consider it's pretty as same as any other human relations as well. So let's take a look to see what's going on here. Now, in mathematics, we often see equations. So equations, for example, y equals to 2x plus 1. You have seen this many times so far. It's almost like you feel probably bored just looking at this thing. But this also represents the relation between x and y. So then, if there's an x like this, if x equals to 1, then your y equals to 3. So this is one way to represent a relation between x and y. On the other hand, when we draw this graph, so the y-intercept is 1 here, and our slope is 2 over 1. So you go up 2, go 1 here, so there's another 1, and then this is the graph. So look at the graph to understand the relation between the x and the y. That is another way to understand a relation. So therefore, we're talking about the graphs. All right, so as soon as we started talking about the graphs, now we are encountering this one, and I believe I already told the story. And there's a coordinate system, and this two-dimensional plane is called the Cartesian plane. All right. Now I'm not even too sure whether I told the story to my Math 9 or I've already told the story to you guys, the Math 10. In any case, if you have not heard about Rene Descartes, you might want to look up to him, or if I've heard from me, that's just good. So a mathematician, also as well as a philosopher by the name of Rene Descartes, who is a French. In the 1700, 1600, don't remember clearly, invented this x and y coordinates system, so the coordinate system. And since then, the human beings are dealing with the x-axis, y-axis, and this is called the Cartesian plane by his name. I love all these stories because it's very inspirational and it's just interesting. All right, so any point on this Cartesian plane has two readings. One reading is x, how much is on x-axis, and on y. Now, how much is on y-axis? Therefore, you can identify the location of this point. Otherwise, you think about, I just put a dot here. I said this dot is right here. What does this dot right here means? Nobody can identify, nobody can define the position of this dot. However, as soon as I give a Cartesian plane, thanks to be with Rene Descartes, then I can say, okay, well, well, I can say this is a 1, this is a 2, this is 3, this is a 4, and 1, 2, 3, 4. And then this dot here is like, oh, okay, now how much is the x reading? Oh, probably 1.5, sure. And then what is the y reading? Oh, perhaps 2 and 1, 2.1. All right, okay, here we go. So then we can say the position of the point, just shall we say A, has a coordinate that is 1.5 and 2.1. Beautiful. All right, so from here you can also say, okay, well, there's another point B. Well, then you can define where the B is by the same system. Now, furthermore, you can even describe the distance between A, B. You can do a whole bunch of things, right? You can also connect these two dots to have a line. And if you can figure out the equation of the line as you have done many, many times, and then any dot on this line, you shall be able to figure out the relation between the x coordinate and the y coordinate. All right, so this is a complete review from your Math 9. So now you have a coordinate, then you can plug the dot, or you have a dot, and you can give the dot, the point, a coordinate. All right, so now what is relation? Now relation, here says relation set of the order pairs. Well, relation just means the relationship between the x value and y value. Now, for example, x is always your input. Now the relation is y equals 2x plus 1. Then your output is y. Okay, so in this case, if x equals -3, then your y is -5, x equals to 0, y is 1, x equals to 2, y is 5. So this is their relation. Now, this one might be a new concept in grade 10, domain and range. So what means domain? Domain is all possible x values. Range is all possible y values. All right, we will get into this further. All right, so now let's take a look at this couple of examples. Now, for example, we have a relationship, a relation as y equals to 2x plus 1. All right. Now, if we have an ordered pair, now we have -3, that versus correspond with -5, that's one pair. And we have a 0, then we have a 1, that's another pair. We have a 2 and we have a 5, that's another pair. So you can present or represent this relation by so-called ordered pair. Or we can see a table, and we have done this table of values many, many times. So x equals to -3, y is this, da, 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 da. Now this one is new. All right, this one is called mapping notation. Mapping notation. So here we go. You have a set of values, and this set of the values is so-called the domain because it's all x values. And then you have set of the values, which are all y values. Therefore, we call it range. Now, mapping means we map the -3 to 5. So you have -3 map onto 5. You have 0 map onto 1, you have a 2, map onto 5, and this is the relation between x and y. Okay, well, as a graph, sure. This dot is here, which is, what is this one? This is 2 and a 5. All right, 2 and a 5. And then this one is 0 and 1, and this one is -3 and -5. So then plug this dot, and that's also the way to represent this relation. Now take a look at this. So this is, so A, this is a set. This set has 3 coordinates here. A B has this, C has that, and D has all this. So then it says, okay, determine the domain. So the domain of the A, it is x value is 1, -3, and 4. So -3, 1, and 4. Well, this is the order based on a number line, right? Then the range of it, it is this y value. And then that is the range, all right? Domain and range. So you basically is x value, put them all together, y value, put them together. Now, next one is we look at the graph. We can also determine the domain and the range. Compared with this one is we look at all these ordered pairs. We can determine the domain, the range. Now there's no ordered pairs, it's just this graph. So how can we look at the domain and the range? Now, graph 1 is a very typical graph that you will encounter in Math 11. This is a parabola. So this is a quadratic function. Now here, this means this curve go on forever, So you can imagine when it shoots into the universe, They're never ending. So therefore, your x value is cover the whole number line. Your x value cover the whole number line. All right. Now your y value, on the other hand, it shoots forever over that way, but there's a minimum point here. There's nothing down here for y value. There's y value has no -3, no -4. So the minimum is here. All right. So now, so that means your domains all real numbers. Your range is y equals to or larger than -2, because it's every single value after this lowest point is all higher than -2. Okay, in terms of notation about how to write domain and range, I do require all my students know using so-called a set builder notation, set builder notation. All right. So how do I write set builder notation? For example, all real numbers. Anybody that does not read English does not even understand what you're talking about, domain. So here, the set builder notation is like this. Domain using d dot dot. Okay, so a bracket, x. So you see, that means x value. And get a bar, that means all domain means all the possible x value, and x belongs to real number set. Range, bracket, y value, bar, y is larger, at least equals to -2, comma, and y value is also all real numbers. All right, so I do require all of you to write in this notation. When you come back to face time, I will also make sure that everybody do understand my requirement. Now here we go. Now take a look at the B. Now B here is, you look at this, the x value is only in this range. The y value for this graph, because this is just a circle, is in this range. So in this case, smallest value for y is 0. Largest value for y is 1, 2, 3, 4. It's positive 4. Smallest value for x value is -2. Largest value for x is a positive 2. So in this case, again, domain x value, x is smaller or equal to positive 2 and larger or equal to -2. And in this range here, in this section here, x also are all real numbers. Range, that's all y value, and y value is larger equals to 0, smaller equals to 4. And in this range here, the y value is all real numbers. Done. Okay. So I think it would be a bit of tedious for me to tell you this one, and this one. You're going to look at C and E and F by yourself. However, I want to point out this one here. See this one? This graph D. The graph D, they're not continued. You see this? This is called a discrete graph. They just have these 3 dots. It's not a line. There are no x value in between these 2 dots. There's no y value. There's just no value. So only this value xy, this value xy, this value xy. Therefore, domain x value, you see this? X only equals to 0, 1, 2, and 3. They're very limited, 4 values here. Now range, y value, y value only equals to y equals to 0, 1, 2, and 3. All right, so that is how you write domain and range. Okay, we are done with 3.1. Thank you for watching.